and we will discuss the evolution, like how Spark evolved, and and some of the things we will touch on how like what kind of optimization is Microsoft Fabric offering you if you are running the Spark workloads. So a little bit about myself. I am Anu. I'm a senior program manager in Microsoft. So I help ISVs migrate their Spark workloads to Microsoft Fabric or build new Spark applications in Microsoft Fabric. So my passion is to help customers and users, run their run performant Spark applications in Microsoft Fabric. So before joining Microsoft, I was working with Google, right? I was a senior data engineer in Google. I was a senior strategic cloud engineer, but focusing mainly on the data side. I was helping customers migrate their Spark workloads, Hadoop workloads to Google Cloud Platform. Specifically Dataproc and BigQuery. I also collaborated with the product team, Dataproc product team, contributed by reviewing some of the PRDs for Spark History Server. And I also enjoy contributing to community. I have written blogs, I've done videos on, migrating Spark workloads to Google Cloud Dataproc. And I'm also I'm a co-author for a Dataproc cookbook, which is with O'Reilly. We are partnering with O'Reilly, and I'm authoring that book. So that book will be published by early next year, like in the month of February. So that's a bit about myself. So feel free to connect with me in LinkedIn, and if you have any questions in Spark, happy to discuss, brainstorm, or help. So today the session agenda is going to be like we will start with some of the basics, like Spark basics, and some of the best practices that you can keep in mind when you are building a Spark application. And for today's session, you don't have to be a Spark expert, right? You could be a beginner in Spark who is wondering what is Spark, right? Or you could be someone that's that's hands-on data engineer, or or a data analyst that's exploring Spark, that's using Spark, or you could be like a intermediate Spark developer, who is running Spark workloads on any of the platforms like Microsoft Fabric or any of the other managed Spark platforms. So for intermediate developers, Sparklens, the session on Sparklens will be helpful, which is a profiling tool that you can use to profile your Spark jobs. And we will also touch how Spark optimization, some of the Spark optimization, and also about Microsoft Fabric native execution engine. So yeah, and we can make the session more interactive, right? If you have any questions, feel free to chime in, like unmute yourself, and or you can ask your questions. So now we will we will start with what is Apache Spark, right? So like you are a data engineer. Let's take a scenario where you are a data engineer in 2008, and you have to process massive amounts of data, right? So your go-to tool at that time would be Hadoop MapReduce. MapReduce, how it works is it breaks down the data processing into two main stages. One is the map stage and other is the reduce stage. In map stage, the data is processed and transformed into key value pairs. And in the reduce stage, these key value pairs are aggregated to produce the final output. And the intermediate results that I mentioned about, right? These intermediate results are written to disks. And like the intermediate results, when they happen is there is a map stage and there is a reduce phases. Between the map and reduce phases, those intermediate results will be written to disks. So the seek operation, the IO, there is excessive IO involved, and the processing time is very slow due to this excessive disk IO. And then Spark started as a research project in 2009. One of the key innovations, of Spark is its ability to perform in-memory computation. By keeping the intermediate data in memory rather than writing to disk, Spark became significantly performant. So when they did some benchmarking, Spark seemed to be 100% performant compared to Hadoop MapReduce. Um, and then Spark was open sourced in 2010 and was donated to Apache Software Foundation in 2013. It became a top level project in 2014. And by 2014, Spark 1.0 was generally available. I remember during that time I was entering into the industry and I was exploring and getting my hands dirty with Apache Spark. When I was working with Scotiabank, we were so excited. And we were compared to Hadoop MapReduce, Spark seemed super performant to process data. Uh, so this is a bit about Spark, right? What Spark offers is a unified set of APIs, where you can handle different types of data, structured data, unstructured data, and you can also do batch processing, structured streaming, and you can do machine learning. Spark natively supports Scala. It is built in Scala, but it also has robust wrappers for Java, Python, or SQL. It is pretty robust in that aspect. So this is a bit about Apache Spark. Now we will talk about architecture, right? So you might be a beginner in Spark, or a developer that is hands-on with Spark. What happens when you actually hit that submit, right? So one question before I go into this: how many of you have run a Spark code, or how many of you are running like a Spark code in Fabric Spark? You opened a Fabric notebook, and how many of you have hit that run? Okay. And have you yeah, go ahead, Dipankar.
Yeah, and we don't have Fabric, but we're using Snap Sparkle.
Great. Okay. Okay. Yeah. Fabric or any other platform like Synapse or Databricks or Dataproc or EMR, are you running have you ever hit the run? Have you ever submitted the Spark job? Okay. So now, we will see what happens when you submit that Spark job, right? Um, so it has a pretty well-designed architecture. It has three layers. One is the driver and executor, right? And other is the cluster manager. There are three layers. And between the executors and drivers, there is cluster manager. Right. And these executors, they run on nodes, like worker nodes. That could be multiple executors in worker node. These executors are like containers. They are like JVM containers, because Spark is built using Scala, and Scala is a JVM language. These executors can execute that JVM code, right? They are JVM containers. Um, so when you submit a Spark code, what happens is it could be Synapse, or it could be Fabric Spark, or it could be any or even you could be running in local machine, right? The driver, it initiates a Spark session. It creates a logical plan. When you submit a Spark code, right? For example, you are reading something and then doing some aggregation and then writing the results as delta table, right? When you are submitting that, this driver's job is to prepare a logical plan. And then driver, what it does is it talks to the cluster manager. Like most of the managed Spark platforms, they use Yarn as the cluster manager, right? And driver, what it asks the cluster manager is, hey, launch me some resources for the tasks. The cluster manager, it actually establishes the connection between the driver and executors. So what the cluster manager does is it launches some resources. After driver communicates, it launches some resources for the tasks, and then establishes a connection between the driver and the executor. And the cluster manager's job is to just maintain the health of the worker nodes, right? The worker nodes, they actually send heartbeats to cluster manager saying that, hey, I'm alive, or I'm like, I am, something is happening, I'm going to shut down. So the worker nodes, they send heartbeat signals to cluster manager. The driver node, it will assign tasks to executor, and the executors will run the tasks and computations assigned and return back the results to driver. So what we mean by this is, when you actually submit a Spark code, your driver is not actually doing the task. Your executor is doing the heavy lifting of actually doing the computation. Your driver's job is to just prepare the logical plan and talk to the resource manager, like to launch the resources for the tasks to run. And these executors, as I mentioned before, they will run on the worker nodes, and they will run on the worker nodes, and then once it has the results, it will return back the results to driver. So the driver and executor both are JVM processes. So this is a bit about driver and executor, and like what we will what we will discuss further is further a bit on driver, right? I mentioned driver prepares a logical plan, so we will little bit go into what that logical plan is, and then we will also discuss what executor actually does, what is executor's role. Um, so when Spark 1.0 was GA in 2014, Spark core engine, right? It made use of RDD. So what you have to do is, it is a resilient distributed data set. It is a data structure. So the developers at the time, when they were working with Spark 1.0, they have to write the code in most performant ways. They should be Scala SMEs, and they should be Spark SMEs. They should know how to write the code in performant ways. So I will explain what I mean by they have to write the code in most performant ways, right? They have to define the code, how they have to write in such a way that they have to define how the code should be executed. In this example, if we see, right, like in the left example, you see that I'm doing like a reduce by operation, and then I'm doing a filtering. I'm doing some group by, and then I'm doing some filtering, and I'm collecting the results. Right? If I'm writing the code like this, what will happen is, it will execute in the same format. First, it will perform the group by, and then it will do the filtering. So you have to know Spark and a deep Spark expertise and Scala expertise to write the performant code. Basically, you will be doing the filtering first, and then you will do the group by next, right? So what happened was, the community, Spark community felt there is a room to improve. So Catalyst Optimizer was introduced as part of Spark 1.2. And what this Catalyst Optimizer is, it is a query, it is a query optimizer which sits between the Spark core engine and all the libraries like data frame. If I write a library, if I write a data frame code, and if I submit to the Spark driver will internally prepare unresolved logical plan, and it goes through analysis process, basically analysis process, doing some schema check, syntax check, and preparing a logical plan. And Catalyst Optimizer applies rule-based optimization and prepares optimized logical plan. And Spark creates a physical plan from this, optimized logical plan, and applies some cost-based optimization and prepares an optimized physical plan. So at the end of this, an optimized query plan is generated, and this is used to generate performant RDD code. So how does it, how does it, why should we care about it, right? So in Spark 1.0, to generate this performant RDD code, the developer has to write this performant RDD code. And when Spark Catalyst Optimizer in Spark 1.2 was introduced, you are preparing, Spark is going to prepare a logical plan, optimized logical plan, and then optimized physical plan, and it would generate a performant RDD code based on this optimized query plan. So this significantly improved Spark job execution. So like if you notice, right, like with the second this code that I'm showing is a data frame code where I'm doing the similar thing, right? I'm writing a group by customer, and then I'm doing some aggregation, and then I'm doing a filter, right? Filter greater than sales greater than 150. uh, Before Catalyst Optimizer, if you see here, it would actually do the aggregation first and then do the filtering and then show the result, right? But after Catalyst Optimizer takes care of predicate push down, and it also does projection pruning, which is it just takes the column that is needed, selects the column that's only needed, right? And it also filters first, right? So first it does the filtering, and then it applies yeah, it applies the aggregation and then shares the result to the driver. So that's how it optimized the performance of the Spark book. So we saw a bit about driver and how driver generates logical plan. And I mentioned once the logical plan is generated, a physical plan would be generated, right? So what is the physical plan? So that's what we call Spark execution model, right? So here I have written a simple code where I'm reading a list of JSON files, and I'm doing some aggregation, like some aggregation. And in the third step, I'm writing it as a delta table. So these are the three things I'm doing. I'm like a typical Spark job has a read and then intermediate process and then write. So that's exactly what I'm doing in this code. And what I mean by physical plan is when I submit this code to driver, what happens is in Spark, there is a concept called transformation and action. So transformation is like we see that we are doing some group by that is a transformation. So the transformations are lazy. So the transformation won't get kicked in until an action is triggered. So the action actually triggers the computation. So the actions could be read, write, collect, take, count. All these operations or actions. So only the actions, only the actions trigger the computation. So, and the transformations could be two types. There is narrow transformation and wide dependency transformation. Narrow transformation could be doing filtering. So what I mean by narrow transformation is we talked about executors, right? There could be multiple executors that are doing the tasks. Let's take a scenario where I'm running like 100,000, where I'm running filtering on 100,000 records. I'm just filtering records greater than 1,000, right, on a specific column. So for this, that doesn't have to be any shuffle between the executors. Each executors can independently do this processing of greater than 1,000 and then share the results to the driver. But if I'm doing some aggregation, if I'm doing some group by, in that case, there needs to be an exchange of data to come up with the final result. So, for example, if I'm doing a group by country, what will happen is this group by first will be performed in each of the executors, and then finally the results will be exchanged between the executors to come up with the final result. So that is called wide dependency transformation, and that is what we call as shuffle. So if the results or if the data is being exchanged between the executors to come up with the final result, that's what we call as shuffles. So if you see there is two blocks, like block 0 and block 1. I won't go too deep into it, right? Because I noticed like not all of you are like, using Spark every day. But block 0 and block 1 is when you read, when you perform an action, that's where that's one block. So you can say like whenever there is a wide dependency transformation, right? Whenever there is there is a wide dependency transformation where there is going to be shuffle, the driver, when you submit this code, the driver will start breaking after start breaking into blocks whenever it sees the wide dependency transformation. So in this case, it sees the wide dependency transformation in the second step. So the first step will be one block, and then the second step, which is the aggregation, and then the next action is going to be another block. And what the driver does is it will take this block and compile it into set of jobs. And driver is not performing any job. Driver's job is to take this block and compile it into jobs. Executor is the one that is going to perform the tasks. So the driver will start breaking the jobs into stages, and it will further break down the stages into tasks, and eventually the task is the one that is going to run on the run on the actual executor. So if you see here in the if you see 2000, like 687 divided by 2000, which means there are 2000 parallel tasks that are doing the same operation, which is the write operation and or a read operation. They are doing the same operation, but 2000 parallel tasks are doing that. So who is breaking this up, like, right? Like, that's where the physical plan comes into the picture. The physical plan decides this. So we discussed a lot about a driver. Yeah, do you have any questions so far? Before I go to the next part, is it too heavy? I can, if it is too heavy, we can move into the lighter parts as well.
If anyone have any question, please feel free to unmute yourself and ask the question. So far, no question, I know. So
Okay.
we
Okay.
can go.
Okay. Great.
Anu,
Yeah. Go
just
ahead. Yeah.
a very basic question. Like you were talking about the logical plan. So you have created a flow chart there where you have mentioned unresolved logical plan and optimized logical plan. Can you just tell the difference between these two?
Yeah. Yeah, sure. Thanks.
Yeah, thank you.
Yeah, great question, right? So the difference between the unresolved and resolved logical plan is, so first, when you submit a code to the driver, right, it doesn't do any schema check. It doesn't do. It just prepares the high level plan, like whatever you're sharing. Let's take an example. I'm reading an input, and then I'm doing some transformation, and then I'm writing I'm writing as a delta format, right? So first, it doesn't do any schema check, or it doesn't do it doesn't do any it just does basic syntax check, right, on your code. And then the second part is where the logical plan, for the logical plan, it does the schema check. It checks with the catalog to see if if whatever you have added is it has a correct schema, and it has the correct syntax, and that's how it prepares the logical plan. So the difference between the unresolved logical plan and logical plan is both are prepared by the driver. But internally, driver prepares an unresolved logical plan based on the flow that you are sharing, right? Like, hey, input, and then you have to do aggregation, and then you have to do a result check. That's what the unresolved logical plan look like. And then driver, in based on this unresolved logical plan, it goes through this analysis process where it does the schema check, syntax check, and prepares the logical plan. And then in the next step, it applies like a rule based optimization, and prepares optimized logical plan, like I mentioned, like a projection pruning, predicate pushdown. Can I move the filters before, or can I do some column projections? So those are the things that happen in the next stage after the logical plan. Does it clarify?
Yeah. Thank you so much. Yeah.
Yeah, we can even think of unresolved logical plan as before Catalyst Optimizer. Before before Catalyst Optimizer, there is always going to be a plan that is generated by Spark, and then it executes. Yeah, we can also think like that. Yeah. Yeah, but great question, Shakshu. Yeah. So we saw about driver, and now we will actually dive a bit into executor. One of the most interesting topics is executor memory management. So we saw like what executor does, right? Like it is doing the heavy lifting. It is doing the actual tasks. So whenever we run a Spark job, we think like, if we are running a Spark job on 16 core and 64 GB memory, we usually think, okay, entire memory, 64 GB memory is for my data. Entire 64 GB memory is for my processing. So that's how we usually think. But inside executor, there are lots of things that are there. Um, this memory management usually is critical for resolving memory issues, right? What happens is like, so first is the reserved memory, right? The reserved memory is reserved by Spark. It's hard coded in the Spark code. We can check the open source Spark code. It's hard coded in there. The reserved memory is 300 MB. So like no one is supposed to touch this, or no one is supposed to change this reserved memory. So if I am talking about 16 core, 64 GB memory, in that the 300 MB is reserved for for Spark's internal processing. And then there is user memory. So user memory is when you write a Python UDF or when you write a Scala UDF, the user defined functions, or when you write user defined data structures like lists or dictionaries, all of those are going to be stored in this user memory. And the user memory is 25 percentage, right? 25 percentage of the total, around 25 percentage of the total executor memory, and you cannot exceed this, right? If you are storing more, more than it can handle, you will end up in out of memory exception. So this is user memory. And then there is two other interesting parts, which is storage memory and execution memory. Storage memory is when you actually write in the Spark code, when you write cache or when you do persist, those are the things that are going to be stored in the storage memory. And when you do some broadcasting, so broadcasting of RDDs, so those are going to be stored in the storage memory. And if the storage memory is if you are storing something that's exceeding the limit, it will be spilled to the disk. And execution memory is basically like when, as I mentioned, compared to MapReduce, in MapReduce, between the map and reduce, the intermediate results are written to disk. In this case, the intermediate results will be handled in memory, right? So the execution memory is where this is happening. Execution memory holds the temporary and intermediate processing data. Those will be stored in the execution memory. So execution memory also supports spilling to disk, right? When it spills to disk, it degrades performance. So in Fabric, the great thing is the executor core and executor memory is huge, right? Like that is the minimum starts from 4 core, and you can have 8 cores, or you can have 16 cores, you can have 64 cores. So you can decide the cores, and there is also there is also performant SSDs, for when it spills to disk, it's going to spill to SSDs. And the boundary between the storage and execution memory is movable. So when execution memory stores any temporary results, it reaches its limit, and if it needs more memory, then it will take some of the blocks from storage memory, and it will use that and store it in the storage memory. So the boundary is movable. Yeah, this is one of the things. And Spark can even evict some of the storage memory blocks if you need more execution memory. For example, if you're storing UDF, Spark can even evict some of those if your execution memory needs more space. But if your storage memory is more, right? If you're caching something and if your storage memory is more, in that case, Spark won't evict any blocks from the execution memory. Sorry, I mentioned as UDF in execution, in storage memory. In storage memory, it's cached, whatever you are doing, persisting or caching. So those blocks will be evicted to disk when the execution memory needs more space. But if your storage memory requires more space, it cannot evict the blocks from execution memory. Instead, it will write back the results to disk. So, but in Fabric, there are things that are set up to make sure that you don't end up in out of memory executor out of memory exception. So this is a bit about driver. So we saw about driver and executor. Now we will go into little lighter topics. Like we saw some foundational aspects, right? Some of the best practices. Um, so typically you are tasked to process JSON files, right? Your business says that, hey, we have to process lots of JSON files and we have to write it as Delta table. First, we will try to, as a data engineer, you will try to understand the business context and then trying to understand the source and target format. Right, and that is very important for designing the pipelines in Spark. So the team says their source format is JSON, right? They have like 2000 JSON files, and you have to run aggregation and then write back the results as Delta table. So the first step is we can ask the team if they can provide the data in serialized formats like Avro, Parquet, or ORC. The reason is serialized formats, they store data in binary format. And also the schema is inside the files and it is good for efficient storage and processing. And since they have schema inside the files, Spark doesn't have to do any typecasting and it supports schema evolution as well. So the team is saying in this case, they can only provide the data in JSON and XML files, right? That's usually the case, right? They can only provide, they might have a legacy system and which can only generate JSON or XML formats. So in this case, what we can do is, this understanding about XML and JSON, right? Non-serialized formats. These are non-serialized formats. You will store the data in human readable text format, which tends to be less space efficient. Since these files don't have embedded schema in them, Spark has to infer the schema by parsing all the tags, and it has to typecast for each row, each column. And this is a compute intensive operation. And only way it can infer schema is it has to read the whole content and create a valid schema. So what you can do in this case is when reading or processing XML or JSON files, use master schema. Um, that way you will your performance will be more you will see a great improvement in the execution time. Or else you can even infer from a sample set of data. The problem is if the sample set of data doesn't represent all the files, then your reads will fail. So have a sample set of files that reflect the entire data set and infer the schema from samples files and persist the schema. So that way you're using a static schema when you are actually running your Spark jobs. So in this GIF, like I'm inferring schema, and it takes 4 minutes to process. And when I'm actually inferring schema from sample set of files, and then I'm passing that schema, when I'm reading the JSON file, it ran in 37 seconds. So we saved about 3 minutes, when it brought down the performance from 4 minutes and 22 seconds to 37 seconds. So this is one thing, one of the basics. And next part is when we think about Spark job, there are like two parts. One is one is the input format and output format, right? Read, you're doing a read, and then there is a intermediate stage, which is the transformation, and then you're doing the write. We talked about read. Now we will talk about the intermediate part, which is the important part. Um, so there is a concept called partitions in Spark, which is the basic units of parallelism. And for example, let's take a scenario, like if we have like 1 GB of data, and if we partition that 1 GB of data into 100 partitions, right? And Spark, what it can do is it can process these 100 partitions as individual tasks in parallel instead of handling this 1 GB of data in a single thread. It's going to process these 100 partitions in 100 threads. So when we think about the reads, right, we discussed about reading JSON or reading XMLs or Parquet files. When you read, Spark decides the number of partition based upon the file input size. So you can tweak the Spark SQL files maximum partition bytes config a bit, right? Increase it, reduce it, and then you can you can come up with the optimal performance for for this specific job. And with the one thing to keep in mind is your data volume will always evolve. It won't be just the same. So you can tweak this number and benchmark for different set of data. And then there is another concept called collays and repartition. Repartition is used to increase or decrease the partitions, right? For example, if you have like 50 partitions, and if I want, if I have resources, 70 cores to support this operation, and and my data is heavily skewed, what I can do is I can actually apply repartition to increase the size to 70 or 60 equal sized partitions, and then perform the operation. And collays is used to reduce the partition. So, but collays doesn't do any shuffles. When you do repartition, it's going to shuffle the whole data, right, between the executors to make sure that it's equally partitioned. So whenever you want to change the partition size, think of using collays if you want to reduce the partition, but you can use repartition when you want to increase the partition size. And then you can also tweak the shuffle partitions count. Default in Fabric is 200. You can, if you're doing like joins on large amount of data, billions of records, so then you can actually increase this number and benchmark with that. So it always involves experimentation and tuning to find the optimal configuration. So in this example that I have shared here, what I'm doing is I'm checking. I'm doing a count operation on the JSON files that I read. Right, it is actually performed by around 2,000 tasks. 2,000 partitions are performing this task for me. And I'm doing a collays. I'm just reducing it, collays of 200, which means 200 tasks will do the same count operation. So I was just doing a benchmarking where I noticed that the 2,000 tasks seem to be performant like 2 minutes 53 seconds, whereas this took 3 minutes and 10 seconds, which is not a major gap, but I'm just giving giving an idea, like you can performance tune this way. Next would be if from 2000 I would switch to 1000 and check what is the what is the performance looking like. So it always involves experimentation and tuning to come up with the optimal numbers. So one of the advantage of Fabric is yeah, I see a hand raised.
Yeah, just a quick
Yeah.
query. Probably I'm understanding correctly or not. Just wanted to know. So we are talking about the partitioning. It also talks about if a node fails, let's say, when we have partition and all the different nodes are working parallelly, like you mentioned. So
Yeah.
if a node fails, Spark can automatically recover the data using the
Yes.
lineage information, right? So let's say if my one node is failed, but the remaining got successful.
Yeah.
So can I reinitiate and reinforce one particular node, and how to do that? I don't know about this example, if it is relevant to this or not. I'm not sure.
Yeah, it is a great question. Spark has some parameters to there is a parameter to retry, right? Whenever there is a failure, it will, if, for example, you are running and some tasks are failing because of a because of a node. Usually, Spark is intelligent enough to actually queue up, right? Let's assume that a stage has 100 tasks, and we have like 100 executors or 100 tasks running on 100 cores, right? And we got one executor, one executor was not running because of some issue with the node. And what will happen is these set of tasks, let's take it as eight tasks were running on that executor, right? And these 8 tasks will go into the queue. Once the remaining tasks are completed, these 8 tasks will go to the queue on a FIFO basis, and they will run. right? So Spark will handle, there is a dark scheduler, which is there, which will take care of this, whenever there is a task failure, there will be retry, which is a parameter that you can control. Like, hey, try up to 5 times, that you can control. But usually you won't, for a one node failure in a cluster, you won't see a Spark application failing. Because it will route it to, it will route it to the, it will queue it to the, it will queue it to run on the other executors.
Okay, and we still can go and check the reason behind the failure. Probably
Yeah.
we haven't handled that logic properly in the code, and we can do it manually or somewhere. I mean, there must be some way to handle that exception as well. I hope that's possible, right? I haven't seen that
So,
example, so
okay. So are
that's why
you
I'm asking.
sharing like there is a code issue, and if it is failing,
Okay.
what will happen? Is that the question?
No, I'm saying, let's say if there is some data which I haven't handled in my code. So this time there is a different data or a data type
Mhm.
that I've
Okay.
encountered, and my code doesn't handle that, and that's why there is some issue
Mhm.
with the failure. I mean, this time.
Okay. Yeah.
So can I go and do some manual operation to just fix it and just rerun that
Yeah.
particular task? That
Got
can
it.
be done, right?
Yeah, got it. So you have to handle it in the, I have seen it with multiple customers, right? Because the data size is going to be always growing, right? It's not going to be
Yes.
constant. So you need
Yes.
to have checks in your application code, like, hey, if this is the amount of data that we are handling, change the executor size to this, this, or change the repartition to this amount, right? You need to have that. For example, if it is a small sized data, maybe run it on just one executor, or if it is a medium sized data, maybe run it on
Okay.
3 executors of 16 core, or like that. But even to come up with that number, you have to do like thorough benchmarking. So
Okay.
in my previous job, we have actually built a calculator and shared it with the customer to show, like, hey, if the data is this much size, use these calculations, like to come up with the appropriate executor core, executor memory, driver code, driver memory for this specific job. Yeah.
Got it.
Does it make
Got it.
sense?
Yes. Yes. Thank you so much.
Yeah.
Yeah.
Yeah, for that you need to handle on the you need to handle on the coding, coding size. But you in Fabric, from what I have observed, is since the core is not like small cores, it's like even the starting is, as I mentioned, 4 executor core, right? In the on-prem world, usually it's 1 executor core or 2 executor cores. The discussion is between 1, 2, 3 executor core. But now with Fabric, or even Databricks or any other platforms, if we see, they're all offering like huge executor size, to minimize these problems a bit. But to your question, to properly handle the resources and properly handle the performance, we have to handle these things on the application code side.
Got it. Thank you.
Yeah. Yeah, thanks for the question. So the next part is I'll share a bit about 2 things, and then we will quickly dive into another profiling section. Right. So Fabric also offers some features to optimize your Spark code. Maybe you someone who is not a Spark expert, right? If they are developing an application and they are processing some data, they are running some machine learning, and after 10 to 20 to 25 iterations of runs, right? When you click on the run 20 to 25 runs, what happens is, behind the scene, Spark adjusts these parameters that I talked about, shuffle partitions, and then it will also adjust the other parameter, auto broadcast join threshold, and another parameter is maximum partition bytes, which I talked about, like input, controlling the input partition size, input read partition size. So auto broadcast join threshold is when to choose broadcast join or when to not choose broadcast join. If you have data less than say if you're trying to perform a join operation between a 10 MB data and GB of another large file. In that case, Spark will broadcast the small file, the lookup table, to all the executors so that there won't be any shuffles, and it will perform the join. So like Fabric already has these these auto tuning settings for you, right? And in Spark 3.0, there is adaptive query execution. It came with another optimization, which is adaptive query execution to optimize the joins, to handle the partitions queues, and to handle the partitions. To handle the shuffle partitions, basically to reduce the shuffle partitions if needed. So the crux of this is, you don't have to understand everything, but one thing to highlight is Spark community has always been into evolving Spark, like evolving the performance of Spark. So when we noticed Spark 1.x, it had a Catalyst optimizer and Tungsten execution engine, which is I didn't cover Tungsten execution engine, but I mentioned the physical plan is generated into RDD code, and that is where Tungsten execution engine comes into the picture, performant RDD code. And then Spark 2.x introduced a cost-based optimizer. Based on the optimized logical plan, we generate a physical plan, and that physical plan, the optimized physical plan, is going to be a cost-based optimized physical plan. And then in Spark 3.0, it introduced adaptive query execution engine. What it looks for, what is the difference between adaptive execution engine and the Catalyst optimizer is adaptive query execution engine, it looks at the runtime statistics. When your code is running, it's going to look at the runtime statistics, and it is going to optimize the performance of the joins or handling the skews. So if we look at this, this demo, I ran for 20 to 25 times, and then auto tune gets enabled, and it chooses a Spark config, like, hey, this is the maximum partition bytes for your testing, and then this is the auto broadcast join threshold, and this is the shuffle partition. So if it is a 30 megabytes size, then if it is less than 30 mega, if the join is between a less than 30 megabytes file and a large file, then it would choose, broadcast join. So I'll go into the Spark lens profiling, considering the timing. Basically here, what I wanted to share is there are multiple ways you can monitor Spark jobs in Fabric. You have when you run a cell, under the cell you have, it shows the Spark jobs view, which I really like. And you can also navigate to the resources and check the resources usage. And when you click on these jobs or stages, it will directly take you to the Spark UI, where you can check, where you can check all these Spark metrics, executor plans, and the DAGs that is generated. And there are some optimizations done on the Spark UI side, by Microsoft Fabric team. They added diagnostic preview, which is not available in the open source Spark. Diagnostic preview basically can tell, if there is any skew in the data. If you're doing some join, and if you have some non-optimal code that is running, it will show if there is a heavy skew. What I mean by skew is if you have 1,000 cores that is processing the data, and one core that is processing, one task that is processing, 1 billion records, and next thread is processing 5 billion records, and next thread is processing 1,000 records. So those are if the distribution is not proper, that's what we call as skew. So you can get those ideas in the Spark monitoring. I wanted to touch another open source profiling tool quickly. This is a Spark Lens profiling tool. Is an open source profiling tool. You can profile your Spark jobs. If you don't know Spark, right? If you're new to Spark, or if you could be an intermediate developer, if you don't know what to read the Spark UI, this is pretty handy tool which will tell you, so many important information. This is not developed or owned by Microsoft, right? You can refer to the Spark Lens GitHub page. it will help you reduce the application time, and it will also it will also help you evaluate if the application will be performant with less amount of resources. To Chakshu's question, right? So when you are actually running different data, right, like smaller data and then larger data, so Spark Lens kind of profiling tool will tell if your application will be performant even with less amount of resources. In that case, you don't need a large amount of executors that are running. So that way you're also saving the cost. So Spark Lens, basically it reports executor time, driver time, a critical path. So I will little bit touch on what is those, what are those, what are those terminologies, right? So I'm running Spark Lens. Oh, I wish I have this. I wish I have this here. Let me see if I can. Yeah, so I'm running Spark Lens now. I'm running. This is how I run Spark Lens. I create an object and I run whatever code I want to write. Right, I'm reading a JSON file and I'm doing some processing and writing as Delta. I'm just passing between this code snippet. Right, so the listener is listening the Spark code, and what happens is it runs the Spark job, and then it prepares a report like this. In that report, what you will see is it will show us the executor wall clock time. It will show us the driver wall clock time. So if you see, I'm navigating to the bottom here. Yeah. So here it shows this is the important part. It shows minimum possible time for the application based on critical path. If I run this application with infinite resources, how long will it take? It will take just 1 minute and 0.02 seconds to run this job. Minimum possible time for the application with same executors, perfect parallelism, zero skew, 56 minutes and 39 seconds as well. So what is the baseline? This job is running for 56 minutes. The one that you see here, total wall clock time, it's running for 56 minutes and 51 seconds. So when you, the minimum possible time with multiple resources, with so many executors, it can run for 1 minute and 0.02 seconds. But if you run with the same amount of executor with a perfect parallelism, like if I change my code, if I apply the repartition, or if I apply collays if needed, and if there is zero skew, then it's going to be 56 minutes and 39 seconds. So in this case, you don't have to waste time optimizing the code. Your code is good enough. So now it's time to add more resources and see if that is helping with the performance. So that is the kind of metric Spark Lens generates. It also generates even more extensive details, which I'm not diving into. But if you are interested, if you're interested in this, I have actually, if you're interested in this, I have actually written a blog on Spark Lens, so you can actually check it out. It's in Microsoft Fabric official page. I will share that link as well here. You can check it out and review more on what exactly is happening. So this video also shows what kind of metrics Spark Lens is showing. So what I'm doing here is after I read the initial report, I added more executors. Right, I increased from the minimum executor to 5 from 4 to. So initially I was running with 2 executors, 4 core each, and now I increased the executor size count to 5 and 8 cores. So in total, we have 40 cores available for this job. And the execution time is reduced to 8 minutes from 58 minutes. Around 58 minutes, it was running with two executors, and now the time is reduced to 8 minutes. So Spark Lens can help you decide those things, like whether you need to invest your time with the code or you need to add more resources. So based on the profiling report, you can customize like driver cores, executor cores, or auto scaling maximum nodes, or minimum and maximum executor instances. So those are and this is a open source tool, so you can use on any Spark platform. It could be Databricks, it could be Microsoft Fabric, or it could be any Dataproc, any platform. You can actually leverage it and run and see how your Spark job is it running at the it is running at the optimal performance or not. So some of the advantages and limitations I'll quickly touch. So advantages is it is compatible with Spark 3.x after configuring, making few changes. I also wrote a blog on it. So if you go through that blog, you can easily generate a jar for Spark 3.x. And so it is user friendly. You don't need to be a Spark expert to understand this report. Limitations is it's not owned or supported by Microsoft. So the contributor status is also not great. There have not been more active contributors in the past 3 years. So you have to run the Spark Lens report without dynamic allocation. You have to disable the dynamic allocation and run this report. Yeah. The final one I wanted to end this session with is, we talked about various optimization, right? Starting from Spark 1.0, 2.0, 3.0, where adaptive query execution was introduced, and Spark 1.0, we saw that Catalyst Optimizer 1.x, where Catalyst Optimizer was introduced 1.2, right? And then 2.x is where cost-based optimizer was introduced, and 3.x is where adaptive query execution was introduced. So Spark community has always been into optimizing the Spark, but the first three optimizations that I talked about are optimizing the plans, a logical plan, physical plan, and then the generating the runtime statistics, looking at the runtime statistics, and then optimizing, re-optimizing the plan. So these are the optimizations that happened. What happened fast forwarding to 2024 is Microsoft Fabric has introduced Spark native execution engine, and what this can do is it is on the hardware side, right? So your code, it won't be running on you running your code on the JVM, right? It will JVM container. Instead, it will run on the C++. It will translate that to a C++ code, and it will run on the C++ engine. So there are two parts to this, right? There is gluten and velox. When you submit the Spark query, as I mentioned, right, when you look at this diagram, when you submit a Spark job, what happens is the driver takes it and prepares a logical plan, a Catalyst query optimizer plan, and then there is going to be a physical plan that is prepared, and and an RDD code is going to be generated. So once we have this optimized physical plan, when you actually enable this Spark native execution engine, what will happen is there are two parts, which is it is based on open source tooling Gluten and open source Velox. And what this Gluten will do is it will take this physical plan and it will check if this code can be translated into C++ code and run on the Velox engine, right? Yeah, or if it cannot run, it will fall back to the JVM, container. So Gluten prepares another plan, which is called substrate plan, which is like a JSON file. And then Velox takes this substrate plan and then prepares the C++ code. And this C++ code is executed on the Velox engine, right close to the machine. And it uses vectorized processing. So this is an hardware level kind of optimization. We are running something closer to the machine. This optimization is taken it's we can compare it with Photon, right? Which is also a C++ engine. So we have done some performance benchmarking, if we think about the TPCD as 1 terabyte data set for all the 99 queries, the execution time is 4x better compared to OS's Spark. But personally, we have seen customers using this on Delta and Parquet tables and seeing huge performance improvements with native execution engine. Yeah, I see a question or. Yeah. Yeah. Any other questions or any other thoughts?
Yes, Anu. Thank you for this session. Just wanted to know, that I'm currently working on project related to the Databricks and
Okay.
PySpark. So, what type of project or you would suggest that one should have in the repository. Going forward, like in 2025, I'll be applying for the internship positions. So what type
Okay.
of project one should have
Oh,
in the
great.
repository? Yeah.
Great. So are you a student right now, or are you working as an intern?
So currently, I have experience as a software engineer
Okay.
uh, back in India.
Yeah.
But currently, I'm a student here at Humber College, and next year I have to apply for the internships. So I'm currently working on my profile and
Okay.
working on some of the projects. Yeah.
Oh, great, great. That's great to know. Like, yeah, it's great that you're getting your hands dirty with PySpark on Databricks, right? So
Yes.
what you could additionally do is, so there are a lot of people who who already know a bit of Spark and or other data processing frameworks, right? How one could differentiate here is, Spark is an open source platform, right? So maybe you can see if you can contribute, right? There are two parts. First, when if you want to go deep dive into Spark, first understand the backend, like how Spark operates, right? So those are the things that interviews will cover. During the interviews, they won't ask, hey, write a Spark code to process this. No, they won't ask. They will try to see if you know about driver, if you know about executor, if you know how the execution plans are generated, right? If you know the internal details of Spark. So that's what during the interviews they look for, because that is critical to optimize the Spark code, to optimize the Spark application. So that is one side, right, for to clearing the interviews. But for your own personal learning, I would say, try try testing out Spark to its max, right? Like if you're working on Databricks, try structured streaming, right? Spark structured streaming, pick a stream from Twitter, and then write it to Delta table and see if it is performant or what are the issues. Maybe if you find some issues, connect with the Databricks team and share the feedback. So that way you are actually collaborating with the Databricks team as well, right? So it's more like it's a kind of networking as well. Or write a blog about a blog, if you like about something, you can write a blog about that. And one other piece, if you really like hands-on coding, another thing what you could do is you can look at the open source Spark, or what you don't like about the current PySpark, right? Maybe you can see if you can contribute to that. Maybe there are some there are some things in Scala which is not in PySpark, right? Which is not in the PySpark wrapper. Maybe you can contribute to that. Maybe you can look for optimizing the Python UDFs. Looking at ways to contribute to the open source itself is a good idea. For example, native execution came up. So native execution engine, right? Like the Fabric native execution engine, it is based on open source as well, right? Like it is based on Gluten and Velox. So set up your Spark. Don't you? I understand that you are using Databricks, but try to set up Spark in local machine. So that way you will learn a lot about. The Spark UI and the server, what is happening with the driver, executor, those internal details. And then, and then what you can do is you can try out even this Velox, and you can integrate Velox, Gluten. It is all in open source. You can integrate those in your local machine and try it out. Or Delta, right? Delta is also open source. Include add that to your local library, and then test it out in local machine. So I would say that way you will dig deeper into Spark. But to get internship jobs, right? We have to see how how we are competing with others, right? There are a lot of people who might be just working with Spark, exploring Spark, but if you have contributed to even a documentation in open source Spark, that's a great thing, right? Like you have taken the initiative and you have contributed. So that's a great thing. So you can you can look for how you can differentiate yourself from others, by contributing contributing to the Spark community.
Got it. Thank you so much for your advice. Definitely I'll work on all these points. Thank
Yeah,
you.
great, great. Yeah.
I have a question.
Yeah.
It's related not to Fabric, but it's a Snaps, but again, Spark Pool upgradation. Do you see any share? Because I think we're using 3.1, we'd like to upgrade to 3.4. Do you see any challenges, or do you have any guidance that when you're gonna do it, make sure we do this, this.
So you are in runtime 1.1 or 1.2 right now? Is it?
I can remember the runtime, but Spark Pool is saying 3.1 that we're using. Then you have
Okay.
to move it to 3.4.
Yeah, let me check just quickly. I'm stopping to share my screen. I'll just
Yeah.
quickly check and yeah, yeah, because I want to make sure I'm giving the correct information, right? So let me check what is the runtime. 1.3 was introduced. I think it's Spark 3.5. I think you are talking about runtime 1.1. So let
Okay.
me double check. So you want to know when you are moving from one runtime to other, right? How to what things to consider? Is that what? Yeah, I
Yeah,
can
yeah.
I can talk from the Spark perspective, right? Just yeah, yeah, I can share my screen and show you. Yeah.
Yeah.
So you are on Databricks. You mentioned you are on Databricks, right? Not
Oh no,
Fabric.
we're in Snaps, Azure Snaps we're using.
Okay. Okay.
Yeah, so Snaps they're mentioning. Yeah, when you're gonna go to our Apache Spark pool in Snaps runtime, they
Yeah.
said Apache Spark 3.4 that we need to upgrade. Right now it's at 3.1.
Okay. Okay. Um, so usually with my experience, right, with Spark 3.x, there has Spark 3.x is like there is not like a major update between one version to other. Um, Minor updates like for example XSD support in Spark 3.5, right? Spark 3.5 supports XSD, but the previous version doesn't support XSD when you're reading XML files. So those are the minor updates. It's not like Spark 2.x to Spark 3.x. If it is from Spark 2.x to 3.x, there are so many things that you need to keep in mind. But from my experience, if it is from 3.1 to
3.4, yeah.
yes, 3.4, it won't be a major change when it comes to coding perspective. It is going to be a major change when it comes to mindset, right? Like you're moving from Synapse like platform to Fabric, like so that's going to be there is going to be a platform change. But I'm sure you're running whatever jobs that you are running, in 3.1, you will be able to run it on 3.4. Yeah, that's just my from my experience I'm talking, like
Okay.
there is not going to be like a major if it is 2.x, there are a lot of things that you need to take
Upgrade,
care of.
okay.
Yeah, and especially if it is 1.x as well, because you might be writing a lot of RDD level code, and you might need to optimize it to data frame code. So like, but it is general best practices. Whenever you whenever you write a Spark application, just looking at not writing RDD level code unless we know what we are really doing, or unless we are a Spark expert, right? If we are writing on the data frame code, I don't think there is going to be a hiccups for you, especially you are moving from Synapse to Fabric. It's all part
Well,
of.
for now, what Anu is still in Snaps because we are getting the message saying, hey, it will be retiring. So you need to upgrade it. And it still snaps because we plan to move to Fabric next year, but like next week actually we're planning to just upgrade from 3.2 to 3.4. We're still looking
Okay,
into the code and things like
great,
that. But
great.
hopefully that since you've been expert, you've been working in this specific area, so I'd like to just get your opinion. As you said, it should not be any
It
that
should not
much
be an issue,
challenge.
but it's a good idea to even test it on Synapse itself, like Synapse
Mm.
3.4, and then you can. But I don't see a major, there is not significant things that are happened between 3.1 and 3.4 or 3.5. Like there is not there is no significant changes that have happened. But it's a good idea. I heard you saying that you're going to upgrade it in current Synapse environment, and then only you're going, so which is a great idea. Yeah, like instead of directly moving, I have seen customers who are directly moving from even Spark 2.x to the new platform, which is a major risk, right? But in this case, you're taking the first step of upgrading it in the current environment, and then you're moving. So I don't anticipate major change on the application side. Maybe you might have some questions around the compute or how the environment works. What am I going to do with my libraries? Where is my library store? How am I going to import those libraries to environment? Maybe you can start building some utilities, automation utilities now itself for the next 1 year on how to migrate those utilities to environment, like how to create those environment packages in Microsoft Fabric. There is the environment API available, so maybe you can start writing those codes, or testing out the feasibility, because most of the Spark customers have issues with the library management part, right? So maybe you can test out how robust the library management is.
No, those are very, very helpful. We'll look into it. Thank you so much. I don't know if anyone have any more question. If not, then thank you so much, Anu, for your time, and it's great learning from you. Thank you so much.
Yeah. Thank you so much for the opportunity, Dipankar, and thank you so much, everyone, for attending as well as great questions. Yeah.
Okay,
Thanks,
folks.
Anu.
Thank you, Vasana.
Thank you,
Thanks,
Vasana.
Dipankar.
Thank you.
Thank you all. Thank you.
Thank you. Have a good one. Anu,
Bye.
share
Okay.
that PPT with us.
Yes.
We'll share with the audience. Yeah,
Perfect.
thank
I'll
you.
do that. Thank you. Thank you very much. Bye.
Have a
Bye.
good
Take
one.
care.
Bye.
Bye.
Thanks, everyone. Bye bye.